Let me go to the web page. What you do is you go to, for taking test, you go to module 3 here, chapter 5 and 6. So you need to be finishing quiz for chapter 5 and chapter 6. And going over, you should be going to Zoom meetings. If you didn't understand anything, make sure that you get the idea. Chapter 5 quiz is here, right here. Chapter 6 is quiz is here. Then after you go over, I have a question and answers to chapter 6, chapter 5, and chapter 5 question answer video I took in 2022. There are a lot of resources here. On the day of the test, you go to this one, CHEM 105, test 3, chapter 5 and 6. Then you take the test. There's a bonus paper due on November. It's optional. If you want to make more points, you can go to the bonus assignment page right here and click on it. Then you can follow the instructions. There are topics given there. You have to write a paper with the title, introduction, and discussion, and should have reference page. So after you've done all these, finals going to be on December. I will let you know exact date, depending on whether you are graduating senior or not. Graduating seniors have to take the test early. Let's talk about, I will send emails on chapter finals or finals based on chapter 1 through 6, which we covered. I am going to go to slides and continue from there. Can you see my page on osmosis?
Yes.
Yeah, you didn't. Last time it was not showing up. Osmosis is based on semi-permeable membranes. Osmotic pressure is the pressure necessary required to prevent the flow of solvent, water, into the concentrated solution. Osmosis is colligative property. Therefore, osmolarity is used to calculate the total osmotic pressure of a solution. If you look at the slide here, normally 0.89% volume by volume sodium chloride is the concentration of a sodium chloride used as a physiological solution, saline solution. This is weighed by volume percent. How do you get the molarity of the sodium chloride? Normally weighed by volume percent multiplied by 10, 0.89 multiplied by 10, you get 8.9. That means 8.9 grams in 1 liter solution. Why multiplied by 10? Percentage is 100. Percentage is 100. Liters are 1,000. Therefore, convert 100 to 1,000. You have to multiply by Therefore, sodium chloride in the solution is that converted to moles. You get 0.15 moles on 1 liter. Therefore, molarity of the sodium chloride solution is 0.15. Because sodium chloride is ionic compound, it dissociates into sodium ions and chloride ions. Therefore, osmolarity, molarity of the solution for colligative property determinations had to be multiplied by 2. Osmolarity of 0.89 weight by volume solution is 0.30 osmol. Osmol is molarity as well. Let us do a few problems. A hypotonic solution, osmotic pressure has lower or higher than body fluid. Hypotonic is lower concentration. Hypo means low. Hyper means more, high. Therefore, hypotonic has lower. B is the correct answer. If cells are placed in a hypotonic solution, hypotonic means higher concentration. What will happen to the cells? Cell will shrink. When the cells shrink in a hypotonic solution, that called crenation. Let's answer the question. Water diffuses out of the, this is the correct answer. This hemolysis is when you put in a hypotonic. Therefore, answer is water. C and D are not correct. B is the crenation when the cells are put in hypotonic solution. If the cells are placed in isotonic solution, equal flow from cells to solution. That's the correct answer. If two solution concentrations are, first one is low, so this is higher. During the osmosis, net flow is water from the dilute solution to the concentrated solution. D is the correct answer. Let's answer a few more questions. This is about crenation. Crenation is a red blood cells occurs when the placed in hypertonic. That's what he said. This is the correct answer. If you have .0.5 molar solution, we talked about saline solutions is 1.89 weight by volume. Therefore, this is less than that. 8.9 is weighted. Therefore, this has to be cells have this when you saline solution. Therefore, this solution is hypertonic. 0.5 is less than 0.89. C is the correct answer. 0.5, 5.0, now it's higher. It should be higher than the concentration of cells. Therefore, it got to be B. If you have 0.8 magnesium chloride solution, now you have to calculate the osmolarity of the magnesium chloride solution. How do you calculate this? This is 8.0. Therefore, multiplied by 10, you get 8 grams per liter. So 8 grams per liter solution has 0.83 molarity. Since there are 3 ions, one magnesium and 2 chloride, this is multiplied by 3, you get 25. So osmolarity of a sodium chloride solution was 0.030. We calculated that. Therefore, this has to be a hypertonic. This is low. This solution is hypertonic. That's how you get the answer B. We get the following solution is hypertonic with that. Do you have questions? You compare these solutions. Find out which is hypertonic. This one is not. Sodium chloride isotonic solution is, we talked about here, 0.89 on the top. This is hypertonic for sure. It's more than 1.89. That could be the answer. So to make sure that you understand you are given a hypertonic solution, you can go there and get the answer, which only one of them is correct. B is the correct answer because it's 0.3 is 0.30 is the isotonic. This is high. This is why it's become hypertonic. I did the calculation for glucose. Glucose, I used this solution. This multiplied 3.2 multiplied by 10. That's how many grams are in 1 liter of solution. Then you convert it grams to moles. 32 divided by 180. Molarity is 0.18. Osmolarity is same as molarity because there's no breaking up in the solution. Therefore, this 0.18 is low value. Even if you calculate for 4.1 solution, you get 2.7 something. Therefore, still lower. Hypertonic solution is B. Red blood cells are placed in a solution and the cells become to swell. When they swell, that means water going into. Solution should be hypertonic. Solution has more water. Therefore, water goes into the cells, eventually create hemolysis, breaking up of the cell. Let's answer a few more questions. There's a diagram given here. There are two solutions, A and B. That's the beginning. This solution is A is 10%, 20%. 20% is, therefore, water should flow from here. When water flows, this level goes up. What water levels in the final level? Therefore, A is the correct answer. If it was other way around, then this is the correct answer. In this case, this is the initial solution. This is lower concentration, 10%. This is 20. Water flows. Which of the following solution has the highest molarity? These all have same molarity. Osmolarity depends on number of particles. This sodium chloride breaks up in water to 2 particles, 3, 4 particles. Aluminum chloride, 4 particles. Barium chloride, 3 particles. Therefore, highest number of particles are here. Therefore, 0.10 multiplied by 4 is the highest molarity. Therefore, answer is C. Which of the following has highest osmolarity? Similar question. Now their molarities are different. Therefore, osmolarity is here is 0.40 multiplied by 2. This multiplied by 2. Osmolarity is here is 0. Barium chloride 0.15 multiplied by 3. This is 4.5. Therefore, B is the correct answer. I didn't calculate it. They multiplied by 0.15 multiplied by 3. This is 1.5. Next question. What is the osmolarity of this solution? We talked about it. The number of grams of weight here is 10 times. 10 times 3.3 is 33. Formula weight is 164. Therefore, when you multiply it by 4, osmolarity is molarity multiplied 4, you get 0.80, which is the answer C. Which of the following aqueous solutions will have the highest osmolarity. If you look at this, these are same molarity. These are all covalent compound that doesn't break up in the water. They have all same. Therefore, they all have the same number of. This is number of grams. They already calculate the same molarity. They don't break up in the solution. Therefore, they have the same molarity, same osmolarity. Which of the following occurs when the blood cells are placed in hypertonic? Hypertonic means concentration higher. Therefore, draws from water is passed from cell to the outside. When cells is passed to the outside, it becomes smaller. So A should be the answer. This is hemolysis in hypertonic solution. Which of the following occurs when red blood cells are placed in hypertonic solution? That's hemolysis. Which of the following occurs when red blood cells are placed in isotonic solution? None of these. Which of the following is associated with desalination of water? Desalination is salt water applying pressure, reversing the osmotic process, reverse osmosis. That's the answer. Which of the following isotonic is? We talked about this. This is the saline solution of sodium chloride. Molarity is 0.15. We also talk about the sun. The same weight by volume. This is the same solution converted to weight by 0.3 here. 1.5, 0.15 multiplied by 2 is 3.3%. 0.3. Okay. This solution is isotonic because osmolarity is same as saline solution. This is not. This has more if you calculate it. That's going to be 10 times aluminum chloride has more particles of ion. Therefore, that's going to be hypertonic. Answer is D. Let's answer this question. Glucose, isotonic to. I did the calculation. You calculate the osmolarity of 0.15. This is 0.3. Osmolarity of sodium chloride 0.3. This solution should be, glucose should be 0.3. Therefore, we convert grams to moles to grams, you get 5.4. This is the answer. You are converting back and forth from molarity to. That's how I got 0.55. Which of the following solution isotonic to osmolarity is 0.30 molar here. This has 3 ions. Therefore, this should be 0.3, has 2 particles. This cannot be because it is larger. Probably A, B. How do you calculate this? There's 3 particles. 0.3 is equal to which of the following solutions are hypertonic? Yes, A is the correct answer. This is isotonic solution. This is hypertonic solution. Which of the solution isotonic was? That hypertonic is this. C is the answer. Saline solution has weight by volume 0.89. How do you prepare 1 liter iso? Suppose you want to prepare, what mass would be you needed? I didn't do the calculation. I will put that in the slides. Isotonic saline solution is 0.89. 0.89. That calculation is not done. What is that promise? Residual concentration of drinking water produced by is very low. 0 is not correct. 40 is in somewhere around here. C is the correct answer. Reverse osmosis is used to separate sodium chloride from water, and you can get fresh water. Hemodialysis is a process where blood is purified in patients with impaired kidney function. The machine blood in here and the blood out here is passed through membrane like this, blood in and out. Blood retain protein platelets in the process and remove urea, salt, waste compounds in the blood. Therefore, person get clean blood. Kidney function is similar to capillary dialysis, artificial kidney. So therefore, it's similar to osmosis, but you can create dialyzer membranes just to pore sizes could be manipulated just to let the urea pass from blood to the urine. That's about the dialysis. Let's answer. When you look at the question here, 308, why is the osmotic pressure of the dialyzer to prevent the loss of glucose from the blood, to prevent, I think it's not prevent sodium and both. It removes glucose, to prevent loss of sodium, prevent sodium loss and glucose loss. But the urea is fast. Which of the following is true when comparing dialysis membrane to osmotic membrane? Both membranes allow solute particles to pass through. And osmotic has larger opening than dialysis membrane. Both membrane allows solute particle pass through, and osmotic membrane has larger opening than dialysis. To me, it looked like A. Both membranes allow solute particles to pass through. I'm not sure about larger opening than dialysis membrane. None of these. So they are completely different. Which of the following is true when comparing dialysis membrane to semi-permeable membrane? Both membrane allows solvent to pass through. Oh, this is solute. Dialysis allows, I was reading this as solvent. Therefore, all are not true. Which of the following in problem 310? Both membranes pass through. I'm not sure about this. Both membrane solvent pass through an osmotic membrane, larger opening. I'm not sure about that. A should be the correct answer. Which of the following pass through a dialysis membrane? Small solute molecules, macromolecules, not pass through, colloidal particles. This should be the one. Colloidal particles are larger. The greater the number of dissolved particles in solution, lower the osmotic pressure. False. Greater the number of solute particles, greater the osmotic pressure. Pure water has osmotic pressure of 1 atmosphere. False. Pure water don't have a pressure, osmotic pressure. Now we are done with chapter 6. Now the questions for test 3 are coming from chapter 5 and 6. We go over these topics. Some of the questions we go over is in the slides. You have to listen to if you haven't got go on and watch these videos. You can go back to Zoom meeting. And I have gone over these questions, like the ones I am showing here. So you have to review what questions. Most of the questions come from questions given here. I don't want to repeat the questions. Go to the Zoom meeting on the chapter 5, first day of the chapter 5. There are 3 Zoom meetings or 3 or 4 Zoom meetings I have had for chapter 5. So you can find the places where I talked about answer to these questions. I talked about gaseous pressure, how you measure them. These are the questions. So there are going to be few questions on the gas pressure measurements. Unit of gaseous pressure. Then we talked about gas laws. We talked about Boyle's law, Charles' law, Jelusak's law, and Avogadro's law. Now in this question number 23, these are the different laws. Avogadro laws deal with volume and moles of substance when the pressure is held constant, right here. Pressure is and temperature is constant. We come up with the equation V divided by N. V1 divided by N1 is equal to V2 divided by N2. So there are specific gas laws, Boyle's law, Charles' law. We go on over calculations as shown in problem 37 and problem 14 here. So you have to identify the variable that is unknown. Knowing 3 variables out of 4 variables, you can calculate the 4th variable and find the answer to that. So we have gone over this. If you have anything that you didn't get it clearly last time you were watching, go back and find out what these calculations are, how you get the answer. That's all you can do before Friday. So there's a gas law called condensed gas law, which combines all 3 gas laws. Combined gas law combines Boyle's law, Charles' law, and Gay-Lussac law. Then we have ideal gas law. After we done the Avogadro's law. Ideal gas law is this equation. Ideal gas constant is equal to pressure multiplied by volume divided by number of moles and divided by Kelvin temperature. All the temperatures are used in the gas laws are Kelvin temperatures. So make sure when you do a calculation, you convert temperature from Celsius to Kelvin. Avogadro law also defines volume of 1 mole of gas at standard temperature and pressure, which is 22.4 liters. This statement, any gas occupies 22.4 liters. Any gas, 1 liter of gas at STP occupies 22.4 liters. That is coming from Avogadro's law. So these are the calculations we have gone over. This is the ideal gas law, calculating the ideal gas constant. Then we can, in the problem here, we calculate the unknown temperature of the gas in kelvins from the data given in the problem. 1 mole of methane gas occupies 20.0 liters at 1 atmospheric pressure. What is the temperature? So knowing the pressure, volume, and the amount of material N and the ideal gas constant, you can calculate the Kelvin temperature. There are few problems with ideal gas law calculation. Once you know at least one of them, it's much easier to understand how the other calculations are done. The STP is 0 degrees Celsius and 1 atmospheric pressure. 0 degrees Celsius or 0 degrees Celsius is same as 273 Kelvin. We also did problems with Dalton's partial pressure. Dalton's partial pressure, low partial pressure applies to mixture of gases. For example, problem here, a mixture of nitrogen and oxygen right here. You can calculate the total pressure knowing the partial pressure of nitrogen and oxygen and carbon dioxide. So these 3 partial pressures added up to total. If you know total pressure and 2 of the partial pressures, you can calculate the partial pressure. For example, this problem asks you to calculate the partial pressure of carbon dioxide. So you set it up, then partial pressures of nitrogen and oxygen subtracted from total pressure of the mixture gives the carbon dioxide partial pressure. So there are few questions dealing with, I gone over them in the Zoom meetings. So you can go back if you haven't watched them or if you haven't understood how to do the problem. We also talk about kinetic molecular theory. There are assumptions of kinetic molecular theory. There are going to be questions about these assumptions. Some of them directly ask for which concept are true statement of kinetic molecular theory. Then you have to pick the correct ones. Normally, gas law describe ideal gases. Real gases are the ones that we have in real situation. Ideal gases assume there are no intermolecular forces between the gases. Therefore, ideal gas is not supposed to become liquids. If there are no intermolecular forces, they are not supposed to become liquids. In reality, ideal gas are at or near this statement, STP. When we do a lot of gas measurement, they are near 0 degrees Celsius or 273 Kelvin, and pressure is 1 atmosphere. For those gases, ideal gas laws applies. But when the temperature or the pressure is increased, the kinetic energy disruptive forces we talked about, kinetic energy disruptive forces that separate the particles, they become weaker when the temperature decreases and pressure increases. Therefore, they become liquids and solids. So we explain the behavior of ideal gases and what are the consequences of real gases. Real gases at lower temperatures, high pressures, are not ideal. They become liquids and solids because they have intermolecular forces of attraction. So we have asked questions about kinetic molecular theory. We also talk about intermolecular forces. There are 3 types of intermolecular forces. London dispersion are present in one non-polar molecules. Dipole-dipole attractions are present in molecule with permanent dipoles, like in acetone here. Water dipoles in water are NOH dipoles. They are very strong. Therefore, they are considered hydrogen bonds. There are 3 types of strong dipoles: OH dipoles, NH dipole, FH dipoles, which are stronger and which are called hydrogen bonds. So you have to know what dipoles make hydrogen bond. All other dipoles, except these 3, are dipole-dipole, weaker. Hydrogen bond energy is larger. So we ask questions about intermolecular forces based on these 3 classifications. We also had to know characteristic of liquids, solids, and gases. We go know this. We describe behavior of gases in terms of molecules, in terms of covalent bonding between the atoms forming the molecules, intermolecular forces, attraction between dipoles, London forces, hydrogen bonding. So we have questions about intermolecular forces. We can look at the structure and tell what kind of a intermolecular force would be present in the molecule. For example, 166. First molecule, which is butane, 4 carbon atoms, don't have any dipole. Therefore, non-polar molecule, carbon, hydrogen are non-polar bonds, non-polar covalent bonds. Therefore, London dispersion force is the only one that will be present in butane. In the second one, that's the propanol. It has OH group. It can hydrogen bond. Therefore, it will show strong intermolecular forces. The third one and fourth one in problem 167 has dipole, OH, oxygen carbon dipoles. They are weaker than hydrogen bonding, but they are stronger than London dispersion. The lowest boiling point is for lower intermolecular force. Lowest intermolecular force is in the butane. Therefore, it has lowest boiling point. Boiling point is related to hydrogen intermolecular forces. So go through these questions. We also talk about liquid state, about surface tension. Surface tension is force that are present on the surface of liquid. And we also talk about liquid to gas conversion, evaporation and condensation, how it form an equilibrium from the liquid to a gas phase molecules. We explain evaporation and condensation in the beaker with the solvent. So it's the partial pressure on top of the solution called the wave pressure. Vapor pressure of a liquid becomes 760, equal to 762. That's when the liquid start to boil. Boiling point is defined as vapor pressure at which temperature, where the vapor pressure is equal to 760. So this line here going through 760 shows boiling point of chloroform, ethanol, and water, and acetic acid. Acetic acid has the strongest intermolecular force. Therefore, it has the highest boiling point. Boiling point is related to structure and the intermolecular forces. We can compare molecular weights and boiling points and the intermolecular force and describe how the boiling point changes for different compounds. Boiling point is affected by intermolecular forces, also affected by number of electrons. More the electrons in a molecule, larger the London dispersion force. For example, methane has lowest molecular weight, lowest number of electrons. Hexanes have large number of electrons. Therefore, hexane has larger boiling point than the methane. The molecular shape also affects. Linear molecules have lower boiling point than branch in 2,2-dimethyl propane. We talked about that. The molecular shape, branch versus linear. Linear has higher boiling point. Same number of carbon atoms. These are isomers. Isomers have the same molecular formula. But linear molecules have larger London dispersion. We also talk about types of solid. We talked about 6 types of solid: ionic solid, molecular solid. We go on over questions about different types of solid. Given this question, which is a molecular solid, you look at the choices and find out molecular solids are covalent compounds, which are not ionic. So sucrose is the answer. Go over these problems. Phase changes are changes that take place when heat is applied to a particular liquid change to a gas, or solid become a liquid. These are called phase changes. Phase changes are shown in heating curve. The parallel lines are phase changes. Melting is a phase change. Boiling is a phase change. The vertical slope, lines with vertical slopes are when you heat a particular phase. The bottom one is solid. A to B is a heating of ice. C to D is heating of liquid or the water. E and upwards is heating of the gas. During the phase changes, temperature doesn't change when the heat is added. Cooling curve is exactly inverse of heating curve. So you start with the gas and you form a solid at the end, as the heat is removed. We talked about 6 phase changes: fusion, freezing, evaporation, condensation, deposition, sublimation. You should know which are exothermic, which is exothermic is heat is given out during the phase change. Heat is absorbed endothermic. Liquid going to a gas is endothermic because heat is required to break up particles in the liquid to become gaseous particles. Condensation is opposite. Gas to liquid is exothermic. So we have questions about heating curves, cooling curves, and we also talk about phase diagrams. So given a question like this, you can see where the liquid phase is in the middle, solid phase is in the next to the y-axis, solid, liquid. Gaseous phase is next to the x-axis. These lines are phase equilibrium. So you can answer questions given here. Energy and phase diagram. For example, this picture right here, there are lines going from X to Y. X to Y is solid to a liquid, Y to X, liquid to a solid, phase change. So triple point is where all three phases can exist. This is the point A in the diagram, middle point right here. That's about the chapter 5. You go through these sample questions. Then I'm going to go to chapter 6. Do you guys have any question? Solution and colloids. Solutions are called true solutions. Colloids are homogeneous mixtures, but their solute particle sizes are larger. We go over these topics in the chapter 6. Characteristic of solutions. Factors affecting solubility. Concentration unit. What is a good solvent? So go through characteristic described in the question. I have gone over this in Zoom meetings, gone over these problems one by one. So go through Zoom meeting for chapter 6 if you didn't understand how to answer this question. Introduction to mixtures. Most common type of solutions. Which of the following can serve as solvent in the solution? All phases could serve as solvent. Solvent is a major component. If a little gas dissolved in solid, it is a gas solid solution. So there are questions about type of solution. The idea homogeneous mixtures are form is based on the statement like dissolve like. Like means if the solvent and solute has similar intermolecular forces, polar molecules dissolves in polar, non-polar molecules soluble in polar solute. Therefore, formation of homogeneous mixtures is explained. If something doesn't make homogeneous solution or true solution, is called insoluble. Two liquids which are not making true solution are called immiscible. So some liquids are insoluble in each other. For example, gasoline and water. So you have to know how solubility is affected. There are 3 types of solution based on solubility. Saturated, the maximum amount of solute at a particular temperature. Unsaturated is it can take up more solute. Supersaturated is it can hold more than what it normally at the equilibrium at a certain temperature. There are questions about these, about type of solids. You have to know which one will make solutions based on idea like the source like and the intermolecular forces. We also look into structures and predict what is soluble in water. For example, problem 36. We look at the structures. Water-soluble compounds are compounds with OH groups. OH groups are in structure B and C. Therefore, they are most soluble. Least soluble is non-polar molecules. Water is polar. Butane is non-polar. Therefore, least soluble in water is A. They're based on intermolecular forces. So these questions as how one substance from the molecular structure, you can tell based on the intermolecular force, London dispersion, hydrogen bonding, or dipole-dipole attraction, which one will be making strongest interaction and shows more solubility. Least is no least solubility is dissimilar intermolecular forces. Water is polar, therefore butane here is a non-polar, therefore it's least soluble. So we go know this. We also need to describe solubility of ionic compound. We came up with solubility rules, which cations, ionic compound is which cations are soluble, which anions are soluble. So these questions will be which ionic compound is not soluble in water, number 43. Silver chloride is an insoluble salt. That's the answer. So we have many questions about ionic solubility. These are, again, 3 ionic compounds are given. Which one are soluble, which one are insoluble. You have to pick up from based on the solubility rules of ionic compound. Solubility is affected by pressure of gases. Unaffected solubility of a liquid or solid in a solvent is unaffected by pressure. Therefore, pressure is important for gaseous solute. Carbon dioxide is a gaseous solute that goes into water in making carbonated beverages. So as the partial pressure increase, solubility increase. Temperature, on the other hand, increase in temperature decrease the solubility of gas. So there are laws governing solubility, guidelines. Solubility of a substance is a constant at a given temperature. So therefore, you should know how to find the solubility constant, solubility of a solute at a temperature. There are graphs like this, solubility of 3 substances. For example, A increases as the temperature increases. B is also increasing, but to a lesser extent. So you can calculate based on the question, the solubility of solute in different temperatures for different substances. Temperature also affect the solubility of a gas. Temperature increases, solubility decreases. The law that describes solubility of a gas and the pressure is Henry's law. Henry's law is solubility of a gas directly proportional to the partial pressure of the gas above the liquid solution is called the Henry's law. Higher the partial pressure of the gas above the solution, more gas get dissolved in the solution. That's called the Henry's law. We go now calculating concentration of solutions. Concentration is relative amount of solute to the total solution. It's expressed in percent compositions based on weight by weight or volume by volume for liquids, weight by volume for solid in liquids. Weight by volume, weight is used mainly for solid. Sometimes we use for liquid also. A parts per million or parts per billion is similar to percentage, but it is to express small concentration of pollutants in the air and water. Parts per million, parts per billion is even smaller quantity of solute than the parts per million. So we have gone through parts per billion, parts per million. Concentration unit molarity is defined as moles of solute divided by liters of solution. There are calculations that we either calculate percent composition of a solution, either WW, weight by weight percentages, or weight by volume or volume by volume. So they are pretty similar calculations. So you need to calculate percent weight by volume, like in problem 111 in here, saline solution. Now remember, saline solution is about 0.9. Saline solution is isotonic with the blood concentration in the blood. So therefore, isotonic solutions don't have osmotic pressure difference, therefore remain stable. Isotonic means blood cells will remain same size. We're going to talk about osmosis pretty later, in later slides. Concentration unit, most common concentration unit. Molarity concentration unit, moles per liter concentration, percent concentration unit. Now this slide shows how to do ppm, ppb problems. Normally ppm and ppb is similar to percent calculation, percent concentration calculation. But you multiply it by 10 to the 6 in ppm, 10 to the 9 in ppb. So there are examples given here. There's a problem called dilution problem. You calculate the molarity or the volume of a final solution when you add water. Dilution is adding water to make a dilute solution. There are questions here. How you dilute M1V1 is equal to M2V2 relationship. So you find M1 value, V2, whatever unknown, is just like gas law calculation. We talked about electrolytes. When ionic compound dissolve in water, if it completely dissolve the ionic compound, is a strong electrolyte. Weak electrolytes are solutions of ionic compounds which have few ions. Non-electrolytes are the ones don't have ions. Compound don't have ions or molecular compounds. So you can test the conductivity of a solution and tell whether it's a strong electrolyte, weak electrolyte, or non-electrolyte based on these diagrams. Water is a good solvent. It has high specificity. Hydrogen bonding ability is the one that makes most important property that makes water good solvent is hydrogen bonding. We talked about water. What is an electrolyte? Problem 230. Non-electrolyte, which is a non-electrolyte. Answer is C. Hydrogen peroxide is molecular compound. It doesn't break up in water. Therefore, it is a non-electrolyte. So you have to pick up strong electrolyte. Strong electrolyte is except acetic acid. Others are all strong electrolyte. So we talked about colloids, particle sizes. Colloids have 1 to 1000 nanometer particle size. Suspensions settle down. Colloids show Tyndall effect. When you pass the light through the colloids, it shows a path through the solution. It's called a colloid. Solution which is based on the light, behavior of light. If you can see the shadow of the light in the solution, that's a colloid. One extreme, you have large particle size like in milk. Milk contains certain proteins which are large. They scatter light. So we talked about colloids. So we also talk about freezing point depression, properties of solution calculated per mole of substance in water solution. This equation is freezing point depression calculation. We done the boiling point elevation using this equation. There are examples of calculation of colligative properties. Colligative properties are freezing point depression, boiling point elevation, and osmosis. Osmosis is pressure created by separating two solutions, one with the higher concentration and one with the lower concentration. Water passes through the semi-permeable membrane to a concentrated solution. So that's called osmotic pressure. Osmosis uses semi-permeable membrane. The pressure that required to balance out osmotic pressure is called osmotic pressure of the solution. So you have to calculate the osmosis. You have to know the molarity of the solution. Also number of particles of ionic compound. Osmolarity for this solution is 0.15 multiplied by 2. Osmolarity of 0.15 solution of sodium chloride is 0.30. Osmolarity of different substances decide whether they are isotonic, hypertonic, or hypertonic. Hypo, hyper, iso. One of these three. Isotonic with the same osmolarity. Hypertonic is osmolarity with the one is lower. Hemolysis takes place if the blood is put in a hypotonic solution. Water goes into the blood cells and they become enlarged and they break up. Hemolysis. Hypertonic solution, on the other hand, red blood cells shrink, is called crenation. So these questions deal with hemolysis, crenation, and osmotic pressure, hypotonic, hyper, isotonic solution. Dialysis is also related to osmosis. In dialysis, you not only remove water, you remove small molecules. When kidney purifies blood through the capillaries of the kidneys, they remove water, sodium chloride, small molecules, glucose, small molecules, keep the blood plasma, blood cells within the bloodstream. It only removes the waste. Therefore, it purifies the kidneys, purifies the blood. So if a person don't have properly functioning kidneys, they have to undergo dialysis. Dialyzer removes water from the blood to the urine as well as glucose and small. Therefore, it's not semi-permeable only. Semi-permeable means only solvent is passed through the membrane. Hemodialysis involves capillary dialyzer. Dialyzer removes water as well as small molecules like sugar, sodium chloride, and other ways with small particle size. So we gone over osmosis and dialysis. Go through these problems. You will be ready for the test. All right. I'm going to come back on Thursday. If you have any questions, I will be willing to answer them again. All right. Then we have test on Friday. Do you have any questions? I will see you guys on Thursday. Are you guys there?
Yes, we are here.
All right. Do you have any questions?
No.
All right. I will see you on Thursday. Okay.
Okay.
Go over the questions and sample questions. That is in module 3. Okay. Questions I went over multiple choice. I went over chapter 5 and 6 and try to understand simple questions. I'm not going to ask hardest questions. All right. I am going to stop the class for today. I am going to send you passcode for the test Tuesday night. Okay. Test 3 will be open on Wednesday from 8 to 10 p.m. 8 a.m. to 10 p.m. All right, I will probably see you taking test on Wednesday. All right. I'm going to stop the class.